Hi, good day everyone. This is Miss Novi Alcover and we're discussing about sets. The introduction to sets. Now, what is a set? A set for all people or most of the people uh, find it really difficult, but the definition of the set is really simple. What is a set? A set is a collection of objects or things. These objects or things could be the names of your family or your friends. It could be numbers, whole numbers, rational numbers, irrational numbers, integers. These objects or things does not limit into one. Example, we have example A, the set of students attending college in the Philippines. The second example, set of 5, 7, and 9 has the elements of 5, 7, and 9. The example C, the set of natural numbers 1, 2, 3, and etc. Alright, yes. Now, writing sets. How do we write sets? Most of the people use these set writing. The first one is the roster method. What is a roster method? Roster method is a kind or one method of writing a set that's very simple and is used mostly on writing. We have the set A has an elements of A, B, C, D, and E. The order of listing the elements of a set does not matter. So if these elements are interchanged, it doesn't matter in the roster method because it's the same thing. If we have that set, if we have this set A, it's also okay if we write it as the set A has the elements of A, E, D, C, and B. The second method is the set builder notation. What is set builder notation? Compared to the rostering method, set builder notation is more complicated, more sophisticated than the first method. What is a set builder notation? The description of the elements of the set is specifically specified. So those elements should be described in the set builder notation. Example, if we have the simple writing on the roster method, in the set builder notation, we have the set A has the elements of X, such that X is the first 5 letters of the English alphabet. English alphabet, that's A, B, C, D, and E. It's like the roster method, but more complicated. Now, if you have encountered this symbol, it's like an E but curved E. It's a lunate epsilon. Now, what does the symbol lunate epsilon mean in writing sets? The symbol lunate epsilon is used to indicate that an object is an element or a member of the set. We use the symbol the crashed out lunate epsilon, if we wish to show that a number or an object is not an element of a given set. We have an example. We have the set F where its elements are x such that x is a negative integer. So negative integer, that includes from -1 until negative infinity. But then if we have negative 7 is a negative integer. So negative 7 is an element of f. Negative 33 is also an element of f, but then, however, If we have the number 6, 6 is a positive integer, so obviously 6 is not an element of F. There are kinds of sets. What are those kinds of sets? If we have the two different methods in writing a set, there are also kinds of sets. The first one is the equal sets. Two sets are equal if they have exactly the same elements. They have the same number, they have the same name, and they have the same number of elements in the set. Example, we have this one, the elements the set whose elements are 1, 5, and 7. This is equal to the elements to the other set, to the other set having the elements of 1, 5, and 7. The second kind of set is the equivalent sets. Equivalent sets and equal sets are sometimes misinterpreted to some students. What's the difference of the two? Equivalent sets, two sets are equivalent if they have the same number of elements. Number, meaning how many elements in the set. Equivalents do not need to be equal sets, but equal sets are always equivalent. Example, we have this set of operation signs, the signs of addition, subtraction, and multiplication, and another set with the numbers or with the elements of 1, 3, and 5. These sets are equivalent sets. Now, why are they equivalent? Equivalent in the sense that they have the same number of elements. It's 1, it's 2, 3, and the other one is 1, 2, 3. The third kind of set is the empty set. Empty set from its name, empty. A set having no elements is called an empty set or a null set. We use the symbol, the double bracket, or the symbol phi to represent the empty set. The fourth one is the universal set. What is a universal set? A universal set is a set consists of all elements, all objects in your set being considered in a particular problem. The universal set is represented by the letter U. The next one is the finite set. Now, what is a finite set? If in counting the elements of a set, the counting comes to an end. There's an end. Example, when we count how many nails do we have in the body. If we have finite set, we also have infinite sets. Infinite sets, if in counting the elements of a set, the counting never comes to an end. Example, it's like counting how many stars are there in the universe, and that's uncountable. The count never ends. That's a kind of sets. Let's have the next one, which is the subset of a set. A set A is called a subset of B if every element of A is also an element of B. A is a subset of B is written as this statement. A is a subset of B. Now we have example. Example number 1, we have set A having the elements of 3 and 4 is a subset of B having the elements of 3, 4, and 7. As you can see, the elements of set A are in the set B. That's 3 and 4. So technically speaking, A is a subset of B. The next one is the set of F. 10, or having the elements of 10, 7, and 5 is a subset of G having the elements of 5, 7, and 10. You can see that the elements of F is also the same as the elements of G, but this could also be a subset because those elements are in G. The second example, we have write all the subsets of the set in A, B, C, the set A, B, C. You can have the subset empty set, you can have a subset, or you can have the set with an element of A, set having the element of B, and set having the element of C. You can have the set having the elements of A and B, or the set having the elements of B and C, or the sets having the elements of C and A, or just the set itself. It's the set having the elements of A, B, and C. Subsets can be classified into two categories. There are kinds of set and like subset of set. There are subset can have two categories. It's the proper subset and the improper subset. Aside from the spelling or the difference with the letters IM, the proper subset is a subset that is not equal to the original set, while the improper subset is a subset that is the set itself. We could have the example number 2, write all the subsets of set A, B, and C. The first subset is a proper subset. As you can see, it's not equal to the original set, which is the set of A, B, and C. The second one is also a subset. Proper subsets. These are proper subsets. Now the third one is also a proper subset because it's not equal to the original sets. However, the last one is an improper subset of the set A, B, and C because it's the set itself. What is the power set? Power set. Let's consider the set A having the elements of A and B. The subsets of A are phi, or the null set. The set A, the set having an element of A, the set having the element of B, and the set having the elements of A and B. The family of all subsets of A is called the power set of A, which is denoted by the power of A. This power of A is equal to the set of phi, set of the element A, the set of element B, and the set having those elements of A and B. In symbols, power of A is equal to the set of all x such that x is a subset of A. Subset of A, that's a element set, A and B. The cardinality of set. I guess you have encountered this word, cardinality. Cardinality is the same thing as the number of elements in a set. The number of distinct elements contained in a finite set. The cardinality of a set is denoted by various notations like n of A, or cardinality of A, or the absolute value of A, or just A. So, example, we have a set A of the elements 2, 3, 5, 7, and 11. Its cardinality is 5. So you can see there are 5 elements on the set A. That's 2, it's 3, it's 5, 7, and 11. I guess that's it. Thank you very much for watching. This is Miss Novi Alcover. Have a good day.